Okay, page 5. Now in our work on polynomials continuing. So this is a division problem we have set up first. This is work the division problem. This is dividing by something that has more than one term here, n minus 4. So if you have a division problem dividing by something with more than one term, that's when we set up the long division like this. We have to work through this process to get the terms that work for that, see if there's a remainder on this thing. So off to the side on these things, I like to work the individual term divisions off to the side. So my first term is negative 3n to the third, and I'm dividing that by n. So that's negative 3n squared. That's where I'm going to start in my quotient up here. My answer up here is going to start with negative 3n squared. Distribute that to both of these. So that's negative 3n cubed plus 12n squared. So each term of the answer gets multiplied by both of those, and then we see what we've got left when we subtract here. Now subtracting, you got to watch your signs. That's negative 3 minus negative 3, which is 0. And that's 13 minus 12, which is 1n squared. So I'm dealing with these terms next. This one and the next one, 1n squared, is my first term now, so I divide that by n. That's just n, or 1n here. So distributing that one to both of these terms, I got n squared minus 4n. When you subtract that, 1 minus 1 is 0, and 28 minus negative 4 is 32 now. So that's 32n and 12 that I've got left at this stage. One more step because I can still divide the first term by n. So 32n divided by n is just 32. That's going to be the last term of my quotient polynomial up there is 32. So 32 times n minus 4 is 32n minus 128. So subtracting, that's 0 again, and this is 12 minus negative 128 is adding 128, so I get 140 left. That can't be divided anymore, so that's the remainder that I've got on this is 140. So the answer to this thing would be my quotient there that I've got, negative 3n squared plus n plus 32, plus the remainder that I've got over the thing I'm dividing by there, n minus 4. That's the full answer to that one. All right, rest of this page involves factoring in some way or another. So we're on the factoring topic here. This one is trinomial, three-term factoring thing. Any factoring problem, you should first look for a GCF that can be pulled out, but there isn't any GCF for this one. There's nothing in that all of the terms have in common. And we're doing normal factoring on that. I'm trying to find the two factors that go in it. Now, I do have a negative out in front to this thing, and when there's a negative number on the leading term there, I like to get that out of the way. So I kind of do that like a GCF. There's nothing else in common here, but I can take out a minus 1 from it, and that'll make that positive. That's going to make the signs be kind of where I'm used to them. So I think the easiest way to factor that is get the negative 1 out first. We'll treat that like a GCF. And then regular factoring on this. So m squared minus 6m minus 27. The question is, can I split up that negative 6m into a couple of m terms where this box thing will work out with m squared and negative 27 here. I would need numbers that multiply to negative 27 that add up to negative 6. So I got 3 and negative 9. That will work for that if you think through the possibilities. That's the one that works there. 3m and negative 9m are going to have to be the terms inside the box there. So pulling out the inside out stuff, the common factor here is m. This is my negative column on this, so I'll use a minus 9. And this would be m, and this would be 3 that these have in common, so I have m minus 9 and m plus 3. If you didn't factor out the negative 1 on the outside, if you did, you got to keep it there, but if you didn't, you'd have different looking signs in there that could look a little different because that negative would be distributed into one or the other there. but you still should have factors involving the 9 and the 3. We can use factoring to solve equations, and that's what we're back to here, equations. This one's already got the 0 on this side, so it's a polynomial equation. I'm trying to find the solutions. I'm going to try to use the 0 factor property. It's bigger than a quadratic. It's a cubic thing. It's got a cubed term on it. So I'm hoping the 0 factor property works this thing down to smaller pieces that I can handle. So I have to factor this big thing. It's a 4-term factoring problem. So I expect just putting the 4 terms in the box will work to find the factors of this. I don't have a GCF. Again, the 2 goes into some but not all of the terms, so I don't have a GCF to take out of it. So I'm hoping this will work, just dropping these things in order. And taking out your common factors from these. So p squared is in common on that row, and 25 down here. The negatives are on the diagonal on this one with the positive down here. So that pattern, you're going to use a minus in both factors. That's p squared minus 25. And this is 2p that they have in common. That's all working out well so far. And here, these are both divisible by 7. That's 7. Negative 7 times negative 25 is 175. So that all works out in there. Those are the factors so far. 2p minus 7. P squared minus 25. And then still on factoring, we can go further. We have a p squared left. We have to think about whether we can factor that further. And sure enough, this is a difference of squares. That's one of our 2-term factoring problems that fit our different forms. And this one's the difference of squares form. We see that a lot. So the factors that'll work there are p minus 5 and p plus 5. For the factors of that one. So now it's completely factored. Now my property says one of these factors has to equal 0. So either 2p minus 7 equals 0, or p minus 5 equals 0, or p plus 5 equals 0. So I get solutions from each one of those. Solving for p there, you get 7 over 2, positive 5, or negative 5. Those are the solutions to that equation. Should all work in that equation. One more on this page. All numbers that are not in the domain of the rational function. So rational expressions or rational functions is where we've got a polynomial over a polynomial. We've got a denominator to think about. And for domain on these things, we're worried about zeros of the denominator. The restrictions on the domain, the numbers that are kind of off limits here or not in the domain, would be numbers that make the denominator equal to 0. So again, we're looking at a little equation here. Where is the denominator equal to 0? Those would be numbers not in the domain. Would be any solutions of this equation. So it's 169t squared minus 81. Where's that equal to 0? That does factor. Fortunately, you could use square root property on this also, because it's just a squared term. If you factor it, you have to recognize that 169 t squared and 81 are perfect squares, so this is also a difference of squares pattern. So the factors look like the minus and the plus. 13t minus 9 and 13t plus 9. So the 0 factor property tells you either this equals 0 or this equals 0. And we're going to get 9 over 13 or negative 9 over 13 for t. And those are the values not in the domain, because those are the values that make the denominator equal to 0. Doesn't really matter what happens with the numerator on that. The numerator can be anything. These are the values not in the domain.